how's it going? So I know I said that we were going to have strafing, but I think let's go ahead and add vertical look as well as horizontal. Yeah. So what I'm going to need to do is now I'm not just going to have one angle. Okay, so imagine theta is my angle around my horizontal plane, in my horizontal plane, so around my y-axis. I'm also going to bring in another angle called phi, and phi will be my vertical look. So if I were to, well, I'll get into this in a second, but basically it's a rotation around the x-axis for looking up and down. So what I'm going to do is I'm just going to pop in here, and for my camera theta, I'm going to change that to camera Eulers, and just the same as above, that will be a list of floats. And now, because we're using a list, we do not have to return anything. Okay. Cool. So pretty much not much has to change. I'm going to define dy as well to be the deviation in the y-axis. So I'll get the y-coordinate, subtract 240 being half the screen size, and I'm gonna have a condition here to check whether either of my coordinates have changed sufficiently, and that will be done just by taking the taxicab metric, just abs dx plus abs dy. We could do it with individual, like if this is moved or this is moved, but this is a rough heuristic, it'll work fine. So what I'll do is instead of camera theta, I'll have element 0 of camera Eulers, and just the same stuff. And now I'm going to also deal with phi. So phi will be camera Eulers 1. Now, of course, I'll take okay. This will change my look up or down angle, but now usually what I do is clamp that between, well, let's say 90 degrees is straight up, negative 90 is straight down. I like to avoid that because sometimes when we're looking directly up, it can cause issues, and so I'm going to clamp this between negative 89 and positive 89. So if we are below negative 89, we'll just be capped at negative 89, and if we are above 89, we will be capped at the minimum. We'll be capped at 89. Okay. Otherwise, pretty good. We've got those angles working independently. Now I'm going to incorporate this in my camera view. So just the same as before. And then just the same as before, I'm going to unpack things. So I'll say, yeah, theta. And now, if I think very carefully about the order of rotations, imagine that I'm looking straight ahead. So my x-axis really truly is going left to right. My y-axis is up and down. The first thing I want to do is apply my pitch. So look up or down, and then my horizontal plane rotation. So all of this to say, the first thing I'm going to do is do my pitch and then my yaw, as they say. Okay, so I'm just going to sort of minimize that, and I'll go down to, it's going to do a bit of, you know, making license plates, as they say. In other words, just the standard stuff. Okay, so I've got my camera Eulers. I'll go ahead and handle mouse, and then put that in for my camera view. Okay, so let's give this a go. Okay, so I can look left and right. Ooh, something is not right. Oh yeah, of course. Oh my goodness. Rotating around the z-axis? Yeah, that's not right. This should just be around the x-axis. Can't believe I missed that. It happens. Wouldn't be the first time. So left and right, up and down. It doesn't, I don't know, that doesn't feel natural. Sometimes I make these things and I really, like some words, when I was a kid, I said the word straw, and I said the word straw so many times that it lost all meaning to me. And that's sort of what it's like sometimes with these look at functions, is that feels more natural. I don't know, sometimes I forget which way mouse looking is meant to work. But that's fine. Okay, cool. So, really truly, the only thing left for us to do in this camera is incorporate strafing. Because as I said, if I move around, I'm still moving around in world coordinates. Okay, let's get on to that in the next one. See you then. Bye.